So the Richter scale is an example of a scale that's logarithmic because small changes in the Richter number leads to a very large change or a very large severity in the effects of an earthquake. So the Richter scale is used to help us compare the magnitude of earthquakes. So let's take a look at an example here and see how logarithmic functions come into play. On December 16th, 1811, an earthquake occurred near New Madrid. And we want to take a look at the magnitude of that on the Richter scale. So that earthquake had a magnitude of 8.8. And then on October 17th in 1989, there was another earthquake that measured 7.1 on the Richter scale. And this happened in San Francisco Bay. So we want to know how much more powerful was the New Madrid quake than the San Francisco quake. So I'm going to just draw a quick number line here. So it's not drawn to scale by any means. So please keep that in mind because it's going to be a little bit hard for me to draw a logarithmic scale on this space that I have on my iPad because I literally just don't have the space to show the logarithmic scale. But I'll put San Fran earthquake on the left here. Its magnitude was 7.1, and the New Madrid earthquake had a Richter scale of 8.8. So if we calculate the difference in the Richter magnitude of these two earthquakes, so 8.1 minus 7.1, that difference is only 1.7 points. Okay, so the New Madrid earthquake was just 1.7 points higher on the Richter scale. But since the Richter scale is logarithmic, and logarithmic just basically means that if we increase the magnitude by x units on the Richter scale, then the intensity of that earthquake actually increases by 10 to the power of that change. So it's that many times stronger. So it's a power of 10. So I want you to imagine that. So what this means here is this means that the magnitude of the New Madrid earthquake was actually 10 to the 1.7 times stronger. All right, so if you put 10 and raise it to the 1.7 on your calculator, that means that the New Madrid earthquake was actually 15 times. You can use adjectives like stronger, more intense, more severe than the San Francisco earthquake. Okay, all right, let's consider another question. If an earthquake is 1,000 times as powerful as the San Francisco earthquake, what would its Richter scale measurement be? So here, we're kind of going backwards compared to the question that we looked at in question A. So again, I'll draw a number line here. It's not drawn to scale by any means. And I'm going to put San Fran on the left here. So the earthquake in San Francisco on the Richter scale was 7.1. And then we want to consider this other earthquake. So I'll call this another earthquake. And we don't know what the magnitude of this earthquake is on the Richter scale, so I'll call it X. But that's what we're trying to figure out. What is its measurement on the Richter scale? What we do know about this other earthquake is when we compare it to San Francisco, we know that this other earthquake is 1,000 times stronger or more powerful or more severe. Choose your adjective. So since the magnitude on the Richter scale is logarithmic, it's base 10, then what we're saying is we're saying that an earthquake that is 1,000 times more powerful is an earthquake that is 10 to the x power, okay? And so here, 10 to the what power equals 1,000? Well, we know that 10 to the third power is 1,000, so that means x is 3, okay? But 3 here is just how much more powerful the new earthquake is compared to the San Francisco earthquake. So that means on the Richter scale, It's three, you could call it points, 3 points higher than the magnitude of the San Francisco earthquake. So actually, I probably should not call this X. Let me call this variable. So up here, let's just leave it as a question mark. So to answer that, I would take 7.1 and add 3, because this earthquake is 1,000 times stronger, or 10 to the third power times stronger, which gives us a Richter scale reading of 10.1. Okay, so an earthquake with a magnitude of 10.1 is 1,000 times more severe than an earthquake that has a magnitude of 7.1. Okay, now let's take a look at one more example. Okay, so let's consider another earthquake. On December 26, 2004, an earthquake 80 times as there was an earthquake that was 80 times as powerful as the San Francisco quake. And this one actually struck the Indian Ocean near Indonesia. And I'm actually old enough to remember when this happened. Maybe some of you guys remember as well. What we want to ask the question, what was the Richter scale reading for this particular earthquake? So again, let me draw that number line, not drawn to scale. Let's put the San Francisco earthquake on here, right? Richter scale measurement of 7.1. And this other earthquake, which occurred in the Indonesia Ocean, so Indonesia earthquake, right? We want to know what was its Richter scale reading, okay? So this earthquake was 80 times as powerful as the San Francisco earthquake. So that means that its severity was 10 to the x power, right, equals 80. Okay, so here, hopefully you can see that 80 is not a multiple of 10. So it wasn't quite as easy as the last question where we were asked to find 10 to the what power is equal to 1,000, because 1,000 is a multiple of 10. But here we can estimate the solution. So we know that 10 to the first power is 10. And we know that 10 to the second power is 100. And 80 is somewhere between 10 and 100, but probably closer to 100. So this means that we're looking for 10 to the point something, right? And that point something is probably going to be closer to 2 than it is to 1, okay? So how do we find that power of 10? And again, we see that it's going to be a decimal, okay? So this is where it's important for us to understand logarithms. So a logarithm allows us to rewrite an equation that's in exponential form. So we have an exponential equation here. If I could rewrite this and write this as something that's logarithmic, I would be able to solve for x. Okay, so that's what we're going to consider in the next couple of slides here. How can we use the definition of a logarithmic function to help us solve something that is exponential, like this problem? Okay, oops.